Hi everyone, I am M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering in SNS College of Engineering. Today we are going to see about IoT enabling technologies from the subject of Internet of Things. Some of the IoT technologies like wireless sensor network, cloud computing, big data analytics, communication protocol and embedded system. In this video we are going to see about two enabling technologies. First one is wireless sensor network, also called as WSN. It comprises of a distributed device with the sensor which are used to monitor the environmental and physical condition. A wireless sensor network consists of a number of end nodes, routers and a coordinator. Here end nodes have several sensors attached to them. End nodes can also act as a router. Routers are responsible for routing the data packet from end nodes to the coordinator, and then a sink or base station acts like an interface between user and the network. The coordinator node collects the data from all nodes coordinator and also acts as a gateway that connects the WSN to the network. Wireless sensor networks can measure environmental conditions such as temperature, sound, pollution level and wind. Constraints of wireless sensor networks are limited processing speed, storage capacity and communication bandwidth. Here there are a lot of challenges placed by the deployment of sensor networks, which are a superset of those found in wireless other networks. Sensor networks communicate over wireless lossy lines with no infrastructure. An additional challenge is related to the limited, usually non-renewable energy supply of the sensor nodes. In order to maximize the lifetime of the network, the protocols need to be designed from the beginning with the objective of efficient management of the energy resource. Scalability. Sensor networks vary in scale from several nodes to potential several hundred thousands. In addition, the deployment density is also variable. For collecting high resolution data, the node density might reach the level where a node has several thousand neighbors in their transmission range. Then production cost. Because many deployment models consider the sensor node to be a disposable device, sensor networks can compete with the traditional information gathering approaches only if the individual sensor nodes can be produced very cheaply. The target price is less than $1. Then hardware constraint. At minimum, every sensor node needs to have a sensing unit, a processing unit and a transmission unit and also a power supply. Optionally, the nodes may have several built-in sensors or additional devices such as localization system to enable location-aware routing. Thus, additional functionality needs to be always balanced against cost and low power requirements. Then sensor network topology. Although wireless sensors have evolved in many aspects, they continue to be networked with a constrained resource in terms of energy, computing power, memory and communication capabilities. Topology maintenance is one of the most important issues. Research to reduce energy consumption in wireless sensor networks. Then transmission media. The communication between the nodes is normally implemented using radio communication over the popular ISM band. Some sensor network use optical or infrared communication, with the latter having the advantage of being robust and virtually interference free. And then power consumption. Many of the challenges of sensor network revolve around the limited power resources. The size of the nodes limit the size of the battery. The software and hardware design need to carefully consider the issue of efficient energy use. And then data compression might reduce the amount of energy used for radio transmission, but use additional energy for computational or filtering. The energy policy also depends on the application. In some applications, it might be acceptable to turn off a subset of node in order to conserve energy, while other applications require all nodes operating simultaneously. Applications of wireless networks are military applications, transportation, health applications, environmental application, air pollution monitoring, greenhouse monitoring, agricultural sector. In next video, we are going to see other IoT enabled technologies. Thank you.